Here, we are going to look at how to convert polar coordinates into Cartesian coordinates. Or in other words, how to convert coordinates from r at a certain angle to an xy coordinate. Now, to do this, we start with the definition of a cosine, which is x over r. We can multiply both sides times r, and this gives us r cosine theta equals x. We can always use this to determine what x is. Likewise, we can turn around and take the definition for the sine, the trigonomic ratio sine of theta, as being the opposite side of a triangle, y, over r. Now, in this case, we are always measuring from the positive x-axis, going counterclockwise. This enables us to always use the same ratios to find x and y, and in order that we can keep ourselves from getting confused when we're using polar coordinates. So, like as we did with x, sine, we can write r sine of theta equals y. Now, taking a few examples, if we take 5 at an angle of theta equals 90 degrees, and we plug it into these formulas, we will find that 5 cosine 90 equals 0, and that 5 sine 90 equals 5. So we can write 0, 5. Likewise, if we take 5 at an angle of 180 degrees, we plug it into the same formula, we get 5 cosine 180 gives us negative 5. 5 cosine of 180 gives me, that's a sine, gives me 0. So I can write the coordinate as negative 5, 0. If we do this again, for instance, with 2 more examples, 7 at an angle of 65 degrees, and also the last example, 12 at an angle of 200 degrees. Now follow along with your own calculator and check this for yourself. If we do, to find x, we do 7 cosine 65. This gives us 2.96. For the y coordinate, we do 7 sine 65 degrees, which gives us 6.34. We don't need to worry about what quadrant we'll end up in. These equations take care of the whole thing. Likewise, for 12 and 20, we do 12 cosine 200 degrees. We don't need to worry about how big or how small theta is. It gives us negative 11.28. For y, we get 12 sine 200, and we get negative 4.10. Our coordinate becomes negative 11.28 comma, negative 4.10.